All right, this is pre-calculus, the chapter 1 review, and I'm going to be doing this on a separate sheet of paper because I didn't leave myself enough room on here to show my work and do all of that. I'm going to go through these definitions, the midpoint formula or the distance formula, midpoint formula, slope formula. I think that's on the board. If not, I'll put it up there. But anyway, definition of a function. Function is a one-to-one relationship. For every y value, there's one and only one x value. The vertical line test to determine that. Ordered pair. An ordered pair is the way we tell where we are on the coordinate system. Ordered pair would be like 2, -3, or something like that. Standard form, after the Euler's line project, I think we were still struggling with standard form, some of us, but standard form is ax plus by equals c. A, b, and c have to be integers, and a has to be a positive integer. So on some of your Euler line projects where you had the leading coefficient as being negative, that's not standard form. Okay. Slope-intercept form, y equals mx plus b. Coordinates of the point, that's what we call, like if it's 0.23, it's a, or 2, 3. The discriminant is the part of the quadratic formula that's under the radical, b squared minus 4ac. Rational numbers are numbers that I can write as fractions or ratios. Irrational numbers are numbers that I cannot write as a fraction, like 2 or pi or something along those lines. The real numbers encompass both rational and irrational numbers. And when I take a real number and an imaginary number and put them together, I get a complex number. And that complex number needs to be of the form a plus bi. We talked about that in class quite a bit. The coefficient is the number in front of a variable, and the quadratic term is the squared term in a quadratic equation. The linear term is the not squared term in a quadratic equation, and the constant is the term in a quadratic equation that does not have a variable with it. Okay, so these will be in a fill-in-the-blank form in some way or another on the test, except for the formulas. Those aren't part of the formula. Those are just things we need to know and know how to use them, obviously. Okay. That kind of fast. If you have questions about any of those, you can always ask in class. For the first part, then, or the first question, I give you points -3, 4, and the point 4, 8. And we are supposed to, 1, find the length of AB. So that's D, distance formula, square root of the 4x minus the other x value, quantity squared, plus y minus the other y value, quantity squared. And so I get 4 minus -3 is 7. That's going to be 7 squared plus 8 minus 4 is 4 squared. And that's 49 plus 9 plus 65. 65, as I recall, does not simplify. It's divisible by 5, but it's 5 times 13, and 13's prime. So there's no 2 alike that I can simplify that. If I could simplify that, then I would have to put a simplified answer. Okay. For number 2, we're supposed to find the midpoint of AB. So for the midpoint, we take the x plus the other x divided by 2, and the y plus the other y divided by 2. So it looks like my midpoint would be at 1/2 and over to 6. And lastly, for this question, find the slope. So slope is going to be y minus the other y over x minus the other x. 4 over 7. I cannot reduce that fraction, so that is my answer. Okay, number 4. We have negative 5x plus 2y equals negative 8. We have negative 15x plus 6y equals 10. And there's a lot of plans I could go with. I could multiply this top one by negative 3, and it would cancel out the x's. It would also cancel out the y's now that I'm looking at this. So this is kind of a special case where if I do multiply this by negative 3, I get 15x minus 6y negative 24. And then that gives me 0 equals negative 14. And that is a false statement. And so if I'm solving a system of linear equations, these are two lines. And when we ask you to solve this, we're asking you where do those two lines intersect. And when the x's and y's both drop out and we get a false statement, our answer is those two lines do not intersect. Doesn't mean they're parallel. They do not intersect. So this has no solution. Had we gotten a true statement that 0 equals 0 or negative 14 equals negative 14, then our answer would have been infinitely many solutions. There's an infinite number of ordered pairs that would work for that. Okay. We have another one to do here like this, and I'm going to jump to it, and then we'll go back to the other ones there. It's number 7 is 2x plus 3y equals 2, and 6x minus y equals negative 4. Okay. I'm going to multiply this bottom equation by 3, and I'm planning, that's my plan, because this then would be negative 3y, and when I add it to this, the y's would drop out. So I'm going to have 18x minus 3y equals negative 12. The first equation, 2x plus 3y equals 2. I add these together, I get 20x equals negative 10. X is negative 1/2. Okay. And then what I want to do is I want to plug that into either one of these equations. And I'm actually going to go to this top equation. There's no negatives. The numbers are a little bit smaller. So I'm going to have 2 times negative 1/2 plus 3y equals 2. 2 times negative 1/2 is negative 1 plus 3y equals 2. And then I add 1 to both sides. 3y equals 3. And divide by 3, y is 1. Here's the frustrating thing for me is, I go over this on the review worksheet, and I found x, and I obviously just plugged that back in to find y. Because this is the graph of a line, and this is the graph of a line. And where these two lines intersect is the point I'm looking for. And that's what I just found. And then I get to grading this test, after we've taken it, and what I discover is that a lot of people only find the x. I got x equals negative 1/2, good to go, I'm done. You missed half the problem. Because we have to solve for x and y. And our answer should be written as an ordered pair. Where do these two lines intersect? They intersect at the point negative 1/2, 1. That's what I'm looking for when we do that. So, don't make that mistake on the actual test. Okay. And now I'm going to go back to number 5, which is 3x squared minus 4x minus 7. Okay. Now I think I can make that thing factor. If you want to put it in a factor puzzle, you can. 3x squared, negative 7, negative 4x. It's going to be 3x and x. I think if I put the 1 here and the 7 here, that gives me 3x and 7x. And I think I want the 7 negative. And then I check it. That works. That works. That works. So my answer, not my answer, but my factors are the quantity 3x minus 7 times the quantity x plus 1 equals 0. And then when we factor, we set each factor equal to 0. 3x minus 7 equals 0. X plus 1 equals 0. This gives me that x is negative 1. This gives me that x is 7/3. Add 7, divide by 3. So x-intercepts, the solution, roots, the zeros of this function are x equals 7/3 and x equals negative 1. Number 6 has 2x squared plus 5x minus 6. I was a betting person because that one factored. I bet this one doesn't. So I'm just going to go, I'm not even going to try. I'm going to go straight to the quadratic formula. So we get x equals the opposite of b, which is negative 5, plus or minus the square root of b squared, which would be 25, minus 4 times a, which is 2, times c, which is negative 6, all over 2 times a, which is 2 times 2, or 4. Okay? See on the left there, I'm going to have a 48. And recall, when we took this quiz, some people ignored the negative here and the negative here. They just took 25 minus 48. But if I have a negative here and a negative here, that's the first thing I think of, is that I'm going to be taking 25 plus 48 because of those two negatives. And 25 plus 48 is negative 5 plus or minus square root of 73, which I believe is prime. So I can't simplify that. That's not going to become a fraction that I can reduce. Okay, that's the ball game right there. Number 8. We already did number 7. We have the square root of 2x plus 5 equals x plus 1. So this is a radical equation, and for this radical equation, to solve it, we square both sides. When I square this side, I get 2x plus 5. When I square this side, remember that it's x plus 1 times x plus 1, which is x squared plus 2x plus 1. And then I would get this thing set equal to 0. 0 equals x squared. 2x's actually drop out, and I get minus 4. And a couple ways we can solve that. I go back to my factoring. That's the difference of two squares. Factors to x plus 2x minus. You can also move the 4 to the other side, take the square root of both sides. Bottom line, I get x is negative 2 or x is positive 2. And remember that squaring both sides can produce an extraneous root, so we have to check our answers. If I plug in negative 2, I get negative 4 plus 5 is 1. The square root of 1 is 1. And And on the other side, I would have negative 2 plus 1, and that would be negative 1. 1 does not equal negative 1. So that answer gets thrown out. That doesn't mean that that's going to be the answer. It could also get thrown out. I don't think it's going to, but it could. So when I plug in 2, I get the square root of 9 equals 2 plus 1, and that is true. So 2. Okay. Moving right along. That brings us to 4, which is y equals 2x squared minus 8x plus 5. And we have to do all the parabola things to it. So first thing I like to do is find the vertex. The vertex, I use x equals the opposite of b over 2a. In this case, that's going to be 8 over 4, which is 2. And then I plug that in to my original equation. So I'm going to have 2 times 4 minus 8 times 2 plus 5. Let's see, that's going to be 8 minus 16 is negative 8 plus 5 is negative 3. So my vertex is 2, negative 3. My axis of symmetry is x equals 2. My y-intercept, that's when I let x be 0. So if x is 0, I get 0, 5. Okay. And then I need domain. Domain is going to be all real numbers. And I need range. And I like to calculate that after I do the graph. And same with the x-intercept. Okay. So that brings us to the graph. This the hounds are getting restless because it is approaching. Well, it's after 5, and they're supposed to get fed at 5, so they're getting restless. I apologize for the background noise from the rude doggos. Anyway, 2, negative 3 is down here. Looks like maybe I should plug in right next to 2 is 1. If I plug in 1, I get 2 minus 8, negative 6, plus 5, is negative 1. And I can use my axis of symmetry to get a mirror point over here. And then the next point to plug in would be 0. And that would be 5 up here. And then again, use my axis of symmetry. And there we go. So it's not looking like this thing would factor. I don't think it would. So I'm going to go straight to the quadratic formula to find the x-intercept. So x is the opposite of b plus or minus b squared minus 4 times a times c all over 2a. Yeah, I don't know why I wrote 8 in there. 4 times a is 2. I think I was thinking 4 times 2. Anyway, x equals 8 plus or minus. This is going to be 40, and it is going to be 64 minus 40. It's going to be the square root of 24 all over 4. And the square root of 24 does simplify. It's 2 square root 6. Now I can reduce everything there by 2 and get 4 plus or minus the square root of 6 all over 2. So for my x-intercepts, I'm going to say they are 4 plus or minus the square root of 6 all over 2, comma 0. Those are the x-intercepts for this graph. The range, I can look at my graph. My vertex is down here at 2, negative 3. So the range is y is greater than or equal to -3. Open the other way, then of course it would be less than or equal. Okay, so those are all the things for the parabola, the quadratic equation there. Going back to the vocabulary, the coefficient of the quadratic term here is 2. This is the quadratic term because it's the one being squared. Its coefficient is 2. The coefficient of the linear term, this one is the linear term because the x is raised to the first power, and its coefficient is negative 8. And then the constant, which has no x with it, is 5. Just wanted to clarify that with when we had the actual equation right there. And number 16 is 5 plus 3i quantity squared. And so we square this out, 5 plus 3i times 5 plus 3i. We get 25, and then plus 15i plus 15i would be plus 30i, and then plus 9i squared. That becomes 25 plus 30i minus 9. And so 16 plus 30i is our answer there. Verse 17. I to the 73rd power. The closest multiple of 4 would be 72. And I to the 72 would be 1. 1 times I is I. 18. We have the quantity 5 minus I minus the quantity 18 minus 3i. So when I make up these tests, I just use tests that I've used before. I go to different forms of it, and I go in and I change the numbers, same way I generate the review sheet. And I cannot tell you that on this problem, I can't tell you how many people multiplied these together because of the two sets of parentheses. And that's not what we're asking you to do. We're asking you to subtract them. And so we want you to take 5 minus I minus 18 plus 3i. So 5 minus 18 is negative 13, and minus I plus 3i is plus 2i. Not asking you to multiply that out at all. Just want you to subtract. And then the last problem, we have 4 over 1 plus I. Multiply top and bottom by the conjugate, which is 1 minus I over 1 minus I. Then we do that multiplication. At the top, we're going to have 4 minus 4i. At the bottom, we're going to have 1 minus I squared, which is 4 minus 4i over 2, which is 2 minus 2i. I already showed you how to put this in your calculator, in your graphing calculator, and I showed you how to do this in your graphing calculator, and I discovered that I can also put this in my graphing calculator, and it gives me this answer. It gives me the answer I'm supposed to get down here, reduced form. Fortunately, you're not going to be allowed to use your graphing calculator on this test. Or at least that's what I'm thinking right now. So anyway, that's the review worksheet. That's all I have. just like the test. Names and numbers are different. If you need help, as always, come in. Happy to help.